Hello, everyone. Welcome to TXAPA Live. I'm Harold Mullen with TXAPA, along with Jim Warren with TXAPA. Jim, how you doing today?
Very good, Harold. Glad to be here.
Fantastic. Our topic today is about friction. Friction on our roadways. And some of the things we're going to talk about is why friction is so important to us. We're going to talk about what is TxDOT doing about friction on our roadways. What are some of the future opportunities and national trends that are going on? So we're going to have a great discussion today about friction and friction on our roadways. And our guest today to explain and educate us on friction is Richard Izzo. Richard is the Soils and Materials Section Director at TxDOT's Materials and Test Division, a great partner to TXAPA. We've had a long relationship, Richard, working on back when you were in the flexible pavement section and everything else. So, Richard, welcome to TXAPA Live.
Thank you. Thank you. Nice being here.
And I see, I can see that you're in the office, so you're one of the brave guys who made it into the office and have stuck it out today, because today's been kind of a treacherous day on our roadways.
Yeah, with 2 kids and Zoom and my wife using the Wi-Fi and all that business, it's peaceful coming to work.
I like that.
Hopefully she's not watching.
Good call. Good call. Well, we want to jump right into everything. And on a day like today, we always know why friction is so important.
That's for sure.
Roadways, oh my goodness, today in these kind of conditions we've had, we're all searching for that good friction to keep us stable and safe on the highway. So Richard, my first question to you is, why is friction so important to us?
Oh, for sure. So when I think of friction, the first thing that comes to mind is safety. And especially like you mentioned today, it's about skid resistance of pavements. It's about reducing our wet weather accidents. And ultimately, we really want to reduce fatalities in our roadways. And to get into a little of that there, I'm not sure how much people are familiar with some programs out there. The Texas Transportation Commission has a Road to Zero program, and the efforts there are to reduce fatalities in half by 2035 and to reduce them to zero by 2050. So that's a pretty aggressive program. And then TxDOT has a program, the #Industry Texas, and that all stems from the last day of no deaths on a highway is November 7th of 2000. So trying to end that streak. So that, when we talk about fatalities and safety, especially our roadways, there are a couple of things, right? There's behavioral, the distracted driving, the not wearing seatbelts and driving under the influence, or what have you. And then you have your engineering factors, your engineering roadway factors. And that's where we come in. And TxDOT has a wet surface crash reduction program, which was previously called the Wet Weather Accident Reduction Program. So we're heavily involved in that perspective of our programs. And I guess I can get into a little deeper of that, or that can go into another topic of what are we doing today, right? That's something you want me to get in, Harold?
You bet. I think Jim has a question already. Jim?
Yeah. Hey, Richard.
Very good.
Does TxDOT use a rib tire or a smooth tire to measure friction?
Good question. I was going to get into that later.
Okay, go ahead.
Yeah, measuring skid with a skid trailer is with a smooth tire, yes. And I'm trying to remember, I believe that's at 50 miles per hour.
Gotcha. Thank you.
All right, and we'll get to that and just a little bit more details on that in just a little bit. But I just want to echo those comments about end the streak, saving lives on Texas highways. That's something we're very interested in doing. That's something we're really focused on along with TxDOT. And Richard, I just appreciate the work y'all are doing on friction, and that's something we all need to work on continuously, is to make sure that our roadways can be as safe as they can be, so we can make sure we're doing our part everywhere to work on safety. And I just heard on the news today that when we do have some bad weather like this, we need to be looking even further down the road in case we do have those skid opportunities. We need to back away from the car in front of us. We need to be looking 20 to 30 seconds. Usually they say 12 seconds is what you need to be looking at down the road, at least 12. Now they're saying at least 20 to 30 when you're in these kind of conditions. So that's something we need to remember. Let's put more distance between us and the car in front of us, and also look down the road so we can make sure when we do have to hit the brakes, that friction is going to work on that roadway. So
yeah, and just slow down a little bit.
Yeah, there was no doubt we had to slow down, no doubt. So Richard, we know that friction is super important to us. What is TxDOT doing today to help us get to where we want to be on friction?
So there are two main aspects that we're working on. First is our program. I mentioned earlier, we have the wet surface crash reduction program. And aside from that, and I'll get into a little more detail, what's involved in that program is research. And so I'll just start off with the program. So the program is a collaboration of work from the maintenance division, and they actually have oversight of the program. It's also with the traffic safety division, and as well as the materials and test division. So the program, I mentioned the maintenance division, and earlier that Jim asked about skid. So they have a dual role in this, or one for sure overseeing the program, but they're also responsible for running the skid testing throughout Texas for their pavement management program. Also, they have a pavement design group, and with that, and there's the surface aggregate classification. So that's where materials and tests comes in. And we have the aggregate quality monitoring program. And part of that program is to test the aggregate sources and then determine a SAC, a surface aggregate classification. And then it ties back in with the maintenance division because they oversee the pavement design, and pavement engineers, they evaluate the criteria that is used. So pavement engineers, they submit a pavement design, and there's a form that we have. And this form has criteria. So we try to determine the friction demand of that particular project, and then we look at the availability of the friction. So what I'm proposing to use, will that give me enough friction to accommodate the demand? And the demand part, that's on project. That's rainfall. That's the average daily traffic. That's taking into account the geometry, the horizontal curve degree, or the percent grade, several factors like that there. And then you have the availability, and that stems from the mix, the hot mix asphalt mixture type, and the design life, and cross slope of the road, multiple factors there. So all that's tied into that form. So the district's pavement engineer completes that form. It's submitted as part of that pavement design. And then that's reviewed by the maintenance division. And I mentioned earlier, we come in because we oversee the aggregate quality monitoring program. And a little about that program is just we have a list of approved sources. So we test sources. We have 118 sources. We test them at least twice a year. Some sources we may get into testing monthly. If we see that there may be some concerns of borderline test results or any inconsistency or anything like that there. So then we'll develop our catalog with the SAC. And that's our end. Now, one thing I didn't get to was the traffic safety division. So they have the CRIS, the Crash Records Information System database. And what the districts do, they have access to that, so they get the details of their wet surface crashes. So then they have the tools from our three divisions to then come up with a plan because they're required to submit plans annually to address wet weather accidents or wet surface crashes. So it's a conglomerate there. It's all about collaboration and partnering. And of course, we work with producers and so on. So that's ongoing. That's active. That's what we do today. That's what's implemented. Now, so aside from that, if you want to if there are any questions from that there, if you want to pause, or I can go to the next.
Yeah, Richard, what's the process of actually getting into the program? I mean, how long does that take? How many tests are required? I've got a new source in my backyard that I want to sell to TxDOT. It's not a big backyard, but I want to go through the process. Walk us through the process real quickly.
Yeah, great question. We get that frequently. So first and foremost, material needs to be provided to a TxDOT project. We're not a catalog for marketing, in the sense that we're not going to test sources if they're not used on TxDOT work.
Oh, okay.
Now, so you call us, we say, hey, here's the deal. We will run one test for you, one set of tests. So we provide that informational test. So you supply us aggregate, you tell us you had a hot mix, seal coat, what have you, send us X, Y quantity.
Mm-hmm.
We'll run the test. We send you an official TxDOT report. So now you could take that report and then you could market your materials. So,
gotcha.
Of course, it provided it's all in compliance with specs, and then you can, look, I meet item 342 PFC or dense graded, what have you, seal coat. So anyway, then eventually maybe a contractor will use your material, and you don't have to be approved. You don't have to be on the list. So what happens there is that your material will be tested on a stockpile by stockpile basis.
Okay.
So you'll build a stockpile, which the district will come out and sample, will test, and then after it's approved, it could be used on a project. So that gets the ball rolling. So as you're building more stockpiles, we will go out there, or we will communicate with the districts, and they will sample. So we need at least 5 test results more than 30 days apart.
Okay.
So once we get those 5 test results, then we would, considering that the test results are favorable and meeting our specs, and then there's other information such as a mining plan and just general information, then you can get onto the program.
Very good. Thank you.
So best case scenario, it could conceivably be 6 months. That's if you're blowing and going and you're producing a lot and you're building new stockpiles every month. As long as they're 30 days or more than 30 days, there'll be communication with sampling and testing.
Gotcha. Thank you. Appreciate it.
Richard, you talked about the quality monitoring program, and I was just kind of curious as to how many different sources do you have in the catalog now? How many different aggregate sources do we have servicing TxDOT?
Yes. So right now we have 118 approved sources. And like I mentioned earlier, it's not that we're only allowed to use those sources, right? More sources can be used that may be tested on stockpile by stockpile. But our program right now has 118 approved sources. And roughly, I believe, 45 or 46 are SAC A. So we're about 40, 60, 45, 55% SAC A and SAC B. And predominantly limestone. Most of our sources are limestone. The next are gravel, then igneous. Those are our top 3. Then we have the dolomites and sandstone and lightweight. That's the aggregate types that we have approved.
With that,
so
that
Texas
many
is such a.
with that many,
I'm sorry.
I was going to say, with that many people in the program, there's a lot of testing going on from
Yes,
your
sir.
section. How many different technicians do you have running tests and that type of thing in your labs over there?
It's The section, diverse is nice. We have geologists, we have engineers, and then we have our technicians. So I have our lead worker, Michael Dewitzik. I'm sure a lot of people, he communicates with a lot of producers. He oversees the program for us. He's a geologist, and we have professional geologists, professional engineers, so different classification if anyone didn't know that. So we have PGs out there. That's Michael. We have engineer and training. I have a young engineer. He's also working with Michael. And then we have, we've got 9 technicians on staff. Some 5 TxDOT, 4 contract. And in our aggregate lab, now that's our section, right? We're soil, space, and aggregate.
There you go.
Now, in our aggregate lab, we only have 2 TxDOT technicians with 3 aggregate technicians, 3 contract working on aggregate lab. So it's a lot of things to balance, and it's like an assembly line. It's fine-tuned. We try to break down at least a couple of pallets a day. It's a lot of work involved. We run about close up to 2,500 tests a year to maintain this program. Pretty extensive.
That is very extensive. That brings me to the question about testing for, and we briefly mentioned testing for friction out there. Tell us about that process out there on the roadways. How does that testing process work? Who's doing that, and that kind of stuff?
Yes, so that's the maintenance division. They spearhead the skid testing of the roadways, and that's part of the pavement management information system database. So they have a skid trailer, and they call it network level testing. And we're not involved in that part. That's the maintenance division collaborating with the districts in that effort. But I honestly don't know all of their schedule. I believe they try to test the roads I think interstate are every 2 years, and non-interstate, I believe they try to get it all tested every 4 years, something like that. Again, I don't know. I'm not too privy on the exact schedule, but it's pretty a workload right there, trying to get to all of our highways and roadways to get the skid testing done.
You bet. There seems to be a lot of discussion about friction around the country. What are some of I know TxDOT is always kind of out front, kind of leading a charge on some of the new technology, but what are some of the national trends you're seeing when it comes to friction and getting better friction on the roadway?
Yeah, so for the most part, a lot of states that I know of are using the British pendulum test to evaluate friction of their materials, and that's something that we used to do before. I think 2000, we used to use that as part of our friction program. It's that process with polishing aggregate is pretty extensive, and we moved away from that because we don't have the resources. When you're dealing with the number of sources that we test compared to a state that's testing 40, they have a little more latitude, because polishing for the British pendulum is a 9-hour deal. And then it requires water and grit and what have you. So a lot of states are using the British pendulum test. And now we're seeing a handful of states are looking at the dynamic friction test. That's relatively new. And I say that, I shouldn't say relatively new. There's a lot of research done national. There's, I believe, an ASTM test procedure for that. But that's a national, I see a handful of states, and they're all starting to look at that. So it's a device that has a disc and is dropped onto the pavement. It'll run at 50 miles per hour in itself. So we have most of those states, and again, I'm not in tune of how many states are using it, but if I had to guess, I'd probably say up to 10 are mostly using it in a hot mix. Meaning on the road, at the road. There are a few that actually they build pads at their facilities, and then they compare that with roadway with their DFD. It's pretty elaborate. one department, Maryland DOT, has actually extended that to the lab, to where they're actually building rings, test samples in their lab, and using the dynamic friction tester in their laboratory setting. So I'd say the movement is towards the DFT, just because it's something new. It has a laser. It has can get a coefficient of friction. So it's new technology, and it could be run. It's run underwater, meaning the device will squirt water out onto the pavement. So it's getting that wet, that film of water on there, and so that's where it's going. And we are looking at that as well. So, but we're only looking at it from a lab perspective, such as Maryland DOT, and we're building on that. We're adopting that, or adapting to our operation. Since we, I believe they only have 44 sources that they test every 2 years. And so we can't run at their scale. But to answer your question, the movement is towards the DFT for a handful of states.
You got it. That brings us to the future, of course, and what the future looks like. What kind of plans are being made for the future? What kind of actions and processes do y'all have in place looking at the future, trying to get there? What will TxDOT be doing in the future for friction, you think?
And just I'm sorry to backtrack. I don't want to give the impression that states are moving away from the skid trailer.
Mm-hmm.
They're still actively doing that. I'm more talking about, what are they doing from a laboratory, or how are we determining what friction level we need?
Sure.
Right. That perspective. I don't mean to say that people are moving away from the skid trailer. Anyway. So yeah. So part of what we're doing today and what we're doing tomorrow, a lot of it stems on research in Texas. So as you know, we have many great universities in Texas, right? We're so lucky for one state to have, and in no particular order or preference, right? You have A&M, you got UT Austin, UT El Paso, Texas Tech, right? And TxDOT has a great research program. The FHWA helps TxDOT with funding, so we always have say at least 10 or so research projects that are led every September. So right now, what we're looking at, research, something that we don't account for is RAP in our mix. So we make the assumption that RAP has a SAC B, straight up, but we really don't know its contribution towards friction, right? I mean, if you're milling up SAC A mix on interstate highway, what is that contribution to friction? You would think it would have something, right? And possibly more than a SAC B, because you're using SAC A rock in that. Anyway, so that's what we're looking at in one project. We just don't know what is the contribution of that. We feel like, the concern is, the demand, right? The demand is growing, and the question is, do we have the supply of a SAC A to meet the demand? As everybody knows, population is growing, right? Your percent trucks, services, et cetera, what you need. So can we possibly help with that by looking at the RAP? And maybe if you have a project and it's all interstate and you're reclaiming it and using it back in, could you possibly give it a higher value than a SAC B? So that's one project that I think is encouraging. That's very helpful. Something else that we're looking at, I refer to that form that is used, that pavement engineers to determine what SAC is required for a project or is needed to meet the friction demand. Well, that form has been around for a while. It's based on a scoring system, and there are 3 tiers of selections. Well, we don't know if, We really don't, that criteria has been around for years. So we have a project looking at that criteria. We have broken down by speed, broken down by rainfall, average daily traffic. Is that criteria valid, still valid, or could it be improved? Could it be changed? So we're looking at that. We're looking to refine that form. And we're also looking at, and the form is very generic when it comes to the selection of the mix type. So it's very broad. Dense graded, coarse. We're looking at, I think that form needs to be broken down by mix type. Type C versus type D. SMA, DFC, thin overlay mix. The thin overlay mix wasn't around when that form came about. So that is one effort that we got going on, is to hopefully update that form, bring it up to date, and that will help us, hopefully make the right choices. When we need an A, we're putting an A where it's highly justified. So that's those are two ongoing projects that we got going. Now, something that we're going to start in the fall, I believe in the fall. So we talk about RAP. What is the contribution of RAP to friction, right? So we're looking at that. But also what we need to consider is fine aggregate. So you have fine aggregate that's mined from a SAC A source versus a B. Well, one would think that there should be some credit right from that fine, because right now when we look at the SAC A, we look at the +4. And anything below that, could fine aggregate from a SAC A? We don't know. But also part of that is you have your SMA course, you have your PFC course, your thin course, and we all associate friction with macrotexture, right? We have macrotexture and microtexture. And right away we think coarser the better, which it is. It's good. I'm not saying, I don't doubt that, right? You need that coarse macrotexture for friction. However, you still have mixes of fine, right? You have PFC coarse, PFC fine, SMA coarse, SMA fine. I believe, again, I know not to get into Robert Lee. I know he's on your program next week. I'm not trying to steal his thunder or anything. And I may be wrong since I don't deal with hot mix, so I apologize up front. I believe there's a thin overlay mixed fine. What we have seen, and I say we, what I've heard is that these fine mixes are going down with high skid values. So those are predominantly 3/8 or less. Are we, in our decision making, we can't just think coarser is better, right? We got to keep in mind that some of those finer mixes may just be as good. Actually, the few that I've heard about, I know the skid values are pretty high. It's very good. And then generally, I think those mixes get more asphalt content. So it's a win-win type of thing. Not to get off on that tangent.
I know NCAT had, they were doing some research on fine graded versus coarser graded, open graded mixes, and they were finding advantages with both texture and noise, if I remember correctly. So there may be some things there to look at.
Oh yeah, you got functional benefits. Yeah, there's a lot to it. So we're hoping this project that kicks off in September will definitely embark on all that and help us more. That's
Richard, there was a couple of things in there I just wanted to compliment you on. Number one is looking at RAP. I think with the new administration on a national level, the focus on sustainability, what that means, I think we have to be looking at our products and services and being more sustainable. And I think your research trying to apply how RAP will play into that friction, I think that's a very worthwhile project to be doing, especially for the long term. Also, I want to echo your comments about our research partners. You're exactly right. We're so blessed in Texas to have some of the best research universities here to work on our products and things that we do from a roadway standpoint that a lot of different states don't get to enjoy. So two things, you're right on target. Jim, you got a comment?
I did get a question that came in. What's your opinion of having aggregate that's 100% SAC A versus 75 to 25 versus 50 to 50 SAC A, SAC B.
So you're talking about blending?
Blending, yeah, blending material.
That's an excellent question. That's where, well, that's a real, and I mentioned earlier about, what do we have right now that can tell us that a 75-25, 25-75 blend will work, right, in the lab. We really don't have anything in our lab. And however, that's where the dynamic friction test comes in. So try to keep this short-winded. When we were using the polish value, we had ways of looking at different percentages to come up with a polish value. And that's where the DFT could help us in the lab to come up with something like that. Because unless you have test sections from a road, you really don't know. It's very difficult to answer. It really is, to know whether it's 25-75. Because keep in mind also, once you start blending, you still have the issue of crushing, right?
Mm-hmm.
So you got to be concerned there that, you got to address that concern of potential crushing, right? The A crushing the B. So I honestly, there is not an answer for you. However, that's something that we need to look at, because you could, again, minimize the demand there, but we really don't have a way of quantifying it with our current system. But it has to be looked at. It has to be considered, because you're right. Can you get by with the 25-75? Yeah.
All right, good job. Hey, our time is flying by. Any last comments for us, Richard, on friction or the programs y'all have in place and what's going on over there in your section?
Well, all in all, it's a challenge. It's something that we know is a big concern, right? We're all about preventing wet weather accidents. So from an engineering roadway factor, we're looking at that from our testing the aggregate. And it's challenging. It's challenging, but in the end, it's a big collaboration. That's what it really needs. And we need to look at those mixes out there. The districts we got to look at those skid values, see what we have, how can we make adjustments. And again, it's a challenging area, but every day we're trying to make progress.
You bet. Well, great job over there. We want to thank you for being a great partner to TXAPA. You're always open to communication. You join our aggregate committee for their committee meetings. We have lots of good input back and forth, Richard, and we just really appreciate you. Thanks for coming on and talking to us about friction today. Thank you very much.
Yeah, it's always a pleasure, and it's great partnering with the aggregate producers. Great. Texas is blessed with supply and great people to work with.
You bet. Well, thank you so much. I just want to add out there, I hope everybody saw our safety share that we had when you came on and got into the program. It was on heart health. So you want to be sure and take that to heart on your heart health and utilize that information. It was great information that was shared there. So I just want to remind everybody, our safety shares are always on our website. You can go to texasasphalt.org and find our safety shares there. Once again, I want to thank Richard Izzo so much for being our guest today and talking about friction. Next week, we will have, next Thursday at 3 p.m., next Thursday, we will have Robert Lee with America's Materials, a CRH company, to talk to us about friction and mix designs, as Richard was talking about earlier. So we'll talk about those type of things. It's going to be very informative. And a lot of good information will be shared. So, Jim, you have any more comments or anything else for us?
No, just everybody be careful out there. It's looks like we're in for a couple of days of not a whole lot of fun. Slow down, keep your distance, just like you were talking about earlier, and let's make sure everybody's safe to come back next week.
You bet. I want to thank everybody for joining us. Please come back next Thursday at 3 p.m. for another session of TXAPA Live. Thank you. Go get some of that good old Texas sunshine on you out there and put a smile on your face. Thanks a lot.